Okay, guys, so today we're going to continue with lesson 1 from chapter 1. We've read through all of the text, but I told you there's a lot of stuff we can expand on. Okay, so really the rest of this week, we're working on different foldables that teach us a little bit more about what was in lesson 1, chapter 1. Okay, so first, open your notebook to this foldable. It should be glued in there. That was your homework one day last week. Yeah, it doesn't need a title. It's okay. Okay. Also, locate your science vocab cards that we made last week. They should be in a baggie somewhere. Okay, I'm going to take this off, but this is a foldable we're filling out.
I wasn't able to get to it because I was very busy this weekend.
You'll have to do it in study hall.
Okay.
Okay, so what I'm drawing up here, Bryce, is this is your notebook in front of you. This side is the flap, okay? So like from there to there is your atoms flap, but I have it flipped open. Okay, so everybody flip open your atoms flap. Flip open your atoms flap. So you should just see white right here, and over here you should see lines because it's your notebook. Okay? Who can tell me what is the definition of an atom? What is the definition of an atom, Dane? Okay, is that what we put on our note card? Okay, so the smallest part of an element. So this is what we're going to write on the lines. Nope, that's not what I want. So under atoms flap, the smallest part of an element that still has the properties of the element. Oops, no S. Okay, so the smallest part of an element that still has the properties of that element. Do you already have that all written down, Dom? Okay, then just sit quietly. Now, what we're going to add on the flap, so have the flap open. So the front side should say atoms. The back side should be blank. So if I have my flap open like this, I want you to draw a little circle in the middle. And just write P equals N equals, and then just draw some rings around it. And just put some circles. Okay, it doesn't have to be super fancy. We're putting that on the flap. Yep, on the back side of the flap. So if my flap is open, where I can see my definition of atoms, I should look to the left and be able to see that. And I want you to write looks like. When we draw out atoms, they look kind of like that. What do you think the P and the N stand for? Harper?
Protons and neutrons.
Protons and neutrons. Those circles around the outside are our electrons. Okay, and we're going to dive deeper into atoms today. But that's what they're going to look like when we see them. We're going to learn actually how to draw them and how to identify what they are from how they look. Okay, then you can go ahead and close that once you get it done. What is the next term? Lori? Element. So I'm going to write that here. You guys already have it. I'm just going to write it here so we're all staying together. I'm going to write it real small there. So open your element flap. Who can tell me what is the definition of an element? Maya?
The ingredients that make up all other substances.
Okay, the ingredients that make up all other substances. We're going to add a little bit to that. That is the definition, okay? But like I said, we're diving a little bit deeper. So we're going to add, just make a bullet point and put organized on a periodic table. Organized on a periodic table. That's where we find all of the elements in a nice, usually color-coded list. Not really a list, picture. So they're organized on a periodic table. Over on the flap, I want you to write looks like again. And we're just going to draw out one element from the periodic table. Bryson, pick a number between 1 and 118. Bryson. Pick a number, any number. 16? 16 is sulfur, okay? So let's just draw a rectangle. Make it big enough where you can kind of write some stuff in it, not a whole lot. There are lots of different numbers for each element, important numbers for each element. Again, we're going to dive deeper into that shortly. Right now we're just getting it so you can see it, to where when you see it, you're like, hey, that's an element. First thing, he said he wanted to do number 16. That number is always at the top. It means something. Then there's usually an abbreviation that goes with that element. For sulfur, it just happens to be a big S, so usually the S is bigger. Under that, it usually has the whole name. Sometimes if it's a condensed periodic table, the whole name is missing, but the one you're going to get is going to have it. So then under that, let's just write sulfur, really small. I think it's UR, yep, sulfur. And then there's one more number under that oftentimes is a decimal. Okay, so that's like a single element from a periodic table. I pulled a single element from a periodic table to kind of show us what we will see on the periodic table. We just see a whole lot of those. Okay, next thing we're going to do is we're going to do the last two definitions and then we'll come back and draw a picture. Okay, so I'm going to draw my line here. There's my sulfur flap, my element flap. Okay, does everybody have that? Okay, I'm going to move on up. What does my next flap say, Haley? Molecule. I'm going to come on down. So on my book, let's go ahead and write our definition for molecule. What is my definition, Sadie?
The smallest particle of a compound that still has the properties of a compound.
Okay, the smallest particle, is that what you said?
No.
The smallest particle of a compound that still has the properties of that compound?
Yeah.
Scoot up just a little bit more so I can fit it all. What's my last word on my foldable, Harper? Compound. I'm going to write that right here. You guys already have it. You don't have to write this. Harper, what is a compound?
A type of matter of two or more.
What'd you say?
A type of matter of two or more elements.
A type of matter made of two or more elements. So who can remember a compound that everybody in here is familiar with? A compound that everybody in here is familiar with. Reese?
Water.
Water. What is its compound? What's its letters? What? H2O. Okay? So I want you to write under the looks like on compound, or on the flap, write water equals H2O. This is on the flap. Okay, a single molecule of water is made up of, Parker?
Hydrogen and oxygen.
More specific. He said hydrogen and oxygen. How many hydrogen, how many oxygen?
2 hydrogen and 1 oxygen.
Yeah, so a single molecule of water, so let's go up here to molecule, is made up of 2 hydrogens. I'm just going to draw it like this. This isn't necessarily the proper way to draw it, but just 2 hydrogen and an oxygen, H2O. So a single water molecule is 2 hydrogen atoms and an oxygen atom combined together to make 1 water molecule. Okay, a compound is just a bunch of those water molecules together. Okay, so I'm just trying to help you visualize what these are. So these are kind of in order from smallest to biggest. An atom is the smallest part of an element that still has the properties of that element. An element is what makes up everything else. A molecule is the smallest particle of a compound this still has the properties of the compound. And a compound is where we have two or more elements together. Okay, so that's kind of in size, smallest to biggest. Once you have that, I want you to locate the picture that looks like, does everybody have this? Does everybody have this? Okay. You guys will need a green colored pencil, a red colored pencil, and a blue colored pencil. Or crayon. Or if you have pens, that's fine too. Blue, red, and green. So take a second to find blue, red, and green. If it's in your locker, just go grab it. Okay, so pull this to the top of your stack. You will glue it in your notebook later. Right now, just pull it to the top. Okay, you can set your notebook aside for a second. So this is a picture of an atom. Okay? In just a minute, we're going to figure out what element this is an atom of, or what element this atom is representing. First, we're going to add some notes to it. I want you to, let's see. Let's go ahead and label some important pieces. Again, I have two of them up here. I'm going to make it bigger because I really only need one. Can I move it over? Nope. Okay, never mind. I'm going to keep it small so I can write. Okay, first thing I want you to do is draw an arrow to the middle and come out here. It doesn't matter what color. We're just labeling different pieces of this atom. Does anybody remember what the center of an atom is called? Reese? Anybody remember? Abby? Nope. Harper? Nope, it's none of the words at the top of the paper. It's none of the words at the top. It is in our science book, you're right. It is...
The molecule?
Nope, not a molecule. It is called the nucleus. The nucleus is the center of an atom. It is made up of protons and neutrons. Okay, I want you to pick up your red pencil or red pen or red whatever and color in Let's color in just, how many are in there? 1, 2. Let's color in 6 red. 1, 2, 3, 4, 5, 6. Color in 1 more, 7. I think there's some hidden back there. Color in all but 3. And again, this is just to kind of give us a visualization. Then down at the bottom, I want you to take that same red pen or pencil, draw a red dot, write equals protons. Then write located in the nucleus. So the red dots are our protons, and they are located in the nucleus. Then pick up your blue pen or pencil. Color in the other 3 in the center. And in 5th grade, we don't get super specific. You'll learn the proper way to draw these when you're older. We're going to not do them wrong, but we're not doing them everything you're able to do. Okay, then down at the bottom, go draw a blue dot. This one's easy to remember that it's in the nucleus because it starts with the same letters. So what do you think those blue ones are? Neutrons. So the blue are our neutrons. And they are also located in the nucleus. Yes, Harper?
And the dots on the outside are the green.
Yes, so then we're going to color the ones in the rings around the outside. We're going to color these all green. And Harper is correct. Those are the electrons. And they are on, they're called electron rings, but they are on the rings going around the nucleus. Okay, and while you guys are finishing drawing that, I'm going to pass out a periodic table to you. Okay, once you have that, what I want you to do, because we're going to add more to our notes, I want you to flip to the next page. So we have our flaps here with atoms, electrons, molecules, compounds. Turn to the next open page. We're not going to glue this in yet, but I want you to lay it on your paper to where you either have, well, we're going to glue it to the very top of the page where there's some room under it to write. So see how if I set it like this, how I have some lines down at the bottom? So you're putting it on your notebook paper. I'm going to pull up just my whiteboard and try and draw this out. Okay, so on your next page of your notebook, here's my big notebook page. Here's my holes over here. I want you to just set the piece of paper as close to the top as you can. Okay, to where here's our nucleus, there's the rings around it, here's our notes down at the bottom. Okay, so you should have some lines down here to still write on. Over on the side, over here where I don't have anything, I want you to write atom. Okay, because this is an example of an atom. So yep, you're not gluing it in yet because we don't have glue. Nate, next open page. Go. Nope, you're going backwards. Turn to the next page. Now, there's some other things we need to know about these protons, electrons, and neutrons. One thing you need to know about an atom is that the number of electrons is equal to the number of protons. Okay, so let's write that down here at the bottom. I want you to write the number of electrons equals the number of protons. You're writing this down at the bottom. For when you glue in this foldable, you should have some space down at the bottom to write. And you're writing the number of electrons is equal to the number of protons. The number of electrons is equal to the number of protons. That's always true for now. So the number of electrons is equal to the number of protons. Does everybody have that? Okay, and I'm going to go back to the picture just so we can show that on the picture. I'm going to go, where's that one? There it is. Okay, so on this picture, this one's already colored in. Let's count the electrons. Where are the electrons?
On the ring.
On the rings on the outside. So if I count them, I get 1, 2, 3, 4, 5, 6, 7. So did you notice when we were coloring the red circles, I counted 6, but I knew there had to be 7. How do you think I knew there had to be 7? Because I counted the electrons. So then I found that little tiny one hidden in there, and I'm like, okay, there's the 7th one. So then instead of saying find the 7th one, I said color all but 3. Okay, so if there are 7 electrons, how many protons are there? 7, because what did we just write? Number of electrons equals the number of protons. So out to the side, somewhere, and you can do it on the picture itself, I want you to write E equals 7, P equals 7. What do you think that means? Okay, that means this atom that I'm working with has 7 protons and 7 electrons. Now, we're going to kind of work this backwards. Instead of me telling you how to find the number of neutrons, or how do we know what number of neutrons, hurry up. I'm going to tell you that this is a nitrogen atom. Okay, so I want you to write somewhere around the edge, I don't care where, that this is a nitrogen atom. And I want you to find nitrogen on the periodic table that I gave you. Find nitrogen on the periodic table that I gave you. Okay, Brant said that it's number 7 on the periodic table. Okay, so where do you think that 7 comes from? Brant? Where do you think, why do you think they called it number 7? Why do you think it's 7th on the periodic table, Nate?
Because it has 7 electrons.
Okay, and it's actually the number of protons gives it that number, and we're going to talk about what that number is when we break down an element tomorrow. Okay, so the number of protons gives us that top number. So if you know an atom has 15 protons, where am I looking on the periodic table?
That number.
That number, I'd be looking for number 15, okay? Which piece of the atom am I missing? Brady? I know my electrons, I know my protons. Which one am I missing?
Neutrons.
I'm missing my neutrons. So let's go up here at the top and put in. And just by looking at our picture, how many neutrons do I have? 3. Okay? That's not right. We picked the bad one. That's okay. Well, it's not important right now. It will be shortly. What's the bottom number on nitrogen? 14.01. Yeah. It's okay. Okay, so we're going to learn how to find the number of neutrons. Box that in. Where did we get that 3 for this one? Lori?
By looking how many neutrons were in
Yep, by looking how many neutrons were in the center. Important part of this foldable is electrons are on the rings on the outside. Protons and neutrons are in the nucleus in the center. And the number of protons and electrons is the same. Okay, neutrons we will dig in deeper tomorrow when we analyze an individual element on the periodic table. Okay, so your only homework tonight, it's super easy. You can get it done before we start RTI. I want you to glue in this atom into your notebook. Put the periodic table in your science folder because you will need it for tomorrow.